Earth, our beloved blue planet, is a small dot floating in the vast cosmic ocean. Think about it. Everyone you've ever met, all humans who have ever lived, and all the stories ever told happened here. But what if we expand our horizons? Let's go beyond the atmosphere, past the moon and the sun, and embark on a mission to understand the true scale of our universe. First stop, the moon. Located about 238,855 miles from Earth, it seems so close, but that distance is truly impressive. If you drove a car at a constant speed of 60 miles per hour, it would take over 160 days to get there. That's a long time to be stuck in traffic. From this lunar vantage point, Earth appears as a fragile blue and green sphere floating in the black void of space. Have you ever wondered what it's like to look back at home and see a tiny dot shining in the darkness? Continuing our mission, our next destination is the Sun. Approximately 93 million miles separate us from this giant burning star. To give you an idea, sunlight, traveling at an incredible 186,000 miles per second, takes about 8 minutes and 20 seconds to reach us. If we tried to travel this distance in a commercial jet at 560 mph, it would take about 19 years to reach the Sun. That's more time than many people spend in school or work throughout their lives. The Sun, with its heat and vital energy, sustains life on Earth from such a great distance. Have you ever thought about what it would be like without it? It would literally be a global freeze. Now, let's look at Mars, our enigmatic red neighbor. Mars may be about 34 million miles away at its closest approach to Earth, but this distance can stretch to 250 million miles when the two planets are on opposite sides of the Sun. To put this into perspective, traveling to Mars at the speed of a commercial jet would take over 50 years. That's longer than most of us live. This vast expanse of space between Earth and Mars presents enormous challenges for space exploration. The rovers and probes we send to Mars face a long and complex journey due to the constantly changing distances and orbital dynamics. Have you ever imagined the work and engineering required to ensure these robots reach Mars and complete their missions? As we continue to explore the outer reaches of our solar system, we encounter Neptune, the icy giant situated approximately 2.8 billion miles from Earth. This distance is so great that sunlight takes about 4 hours and 15 minutes to reach it. Neptune marks the edge of our solar neighborhood, showing the enormity of our system. Think of Neptune as the distant neighbor you never visit, but know is there. Even at this impressive distance, the Sun still exerts its influence. Launched in 1977, Voyager 1 represents human curiosity and our relentless desire to explore the unknown. This space probe, a true landmark of engineering and science, has been traveling for over 4 decades and is currently more than 14 billion miles from Earth. To give an idea of this epic journey, in 1990, at the request of the renowned astronomer Carl Sagan, Voyager 1 turned its camera back towards Earth to capture a final image. This photograph, known as the pale blue dot, shows our planet as a small point of light lost in the vastness of space. Sagan used this image to emphasize the responsibility we have to care for and preserve our only home, a monumental but essential task. At the far reaches of the solar system, we find the mysterious Oort cloud, a vast sphere of icy objects extending up to an impressive 1.9 light-years from the Sun. A light year is a distance measure used in astronomy to describe the extent light travels in a year. Light travels at a speed of approximately 299,792 kilometers per second, or about 186,282 miles per second. This means that, in a year, light can travel about 9.46 trillion kilometers, or approximately 5.88 trillion miles. To put this into perspective, if we could travel at the speed of light, it would take just 1 second to circle the Earth almost 8 times. This distant and poorly understood region marks the boundary of interstellar space, where the Sun's solar wind finally ceases, and the influence of our star diminishes. The Oort cloud is like the edge of our cosmic neighborhood, a final frontier that challenges our understanding, and prompts us to question what else might lie beyond. This is the point where the sun's influence ends and the vast and unknown realm of interstellar space begins. Farther out, we find Alpha Centauri, the star system closest to our sun, about 25 trillion miles away. Alpha Centauri is approximately 4.4 light-years from us. To give an idea of the magnitude of this distance, with current technology, a journey there would take over 70,000 years. That's longer than the entire recorded history of human civilization. This immense distance underscores the vastness of space and the challenges we face when thinking about interstellar travel. Is there life in Alpha Centauri? Our mission now takes us to the grand scale of our home galaxy, the Milky Way. With a diameter of approximately 100,000 light-years, this vast spiral galaxy houses hundreds of billions of stars, each potentially with its own planetary systems. Have you ever stopped to think that each of these stars might have planets with life? Within this immense structure, there is a small sphere known as the human radio bubble, extending about 100 light-years from Earth. This bubble represents the farthest reach of human influence in the cosmos, the reach of our radio and television transmissions in space. It's fascinating to think that while we're watching TV or listening to the radio, our signals are traveling through space. However, beyond this bubble, it's as if humanity never existed. Any civilization residing in the vast majority of our galaxy would be completely unaware of our presence simply because our signals haven't reached them yet. The scale of the Milky Way is so vast that our entire recorded history is just a whisper in the cosmic wind, undetectable beyond this small bubble. We are truly very small compared to the immensity of the universe. As we reach the limits of our cosmic exploration, we encounter the boundaries of the observable universe, an astronomical wonder extending about 93 billion light-years in diameter. This raises a fascinating question. If the universe is only 13.8 billion years old, how can it be so vast? The answer lies in the nature of cosmic expansion. Since the Big Bang, the universe has been constantly expanding, stretching space, and increasing the distances between celestial bodies. It's like the universe is a balloon being continuously inflated. But what's beyond the observable universe? This remains one of the greatest mysteries in cosmology. Some regions of space are receding from us faster than the speed of light, placing them forever out of our sight. Imagine a boat disappearing over the horizon until it's no longer visible. Consequently, the true size of the entire universe remains unknown and potentially infinite. The observable universe, vast as it is, might be just a tiny fragment of the entire cosmic expanse. We are left with the humble realization that there may always be regions of space, entire galaxies, and wonders we will never witness as they drift endlessly into the depths of the expanding universe. We are just a small blue dot in a vast cosmic ocean, but that doesn't diminish the importance of our existence. On the contrary, it gives us the responsibility to take care of our planet and continue exploring, learning, and growing. If you enjoyed this journey through the universe, don't forget to like the video, subscribe to the channel, and turn on notifications so you don't miss any of our upcoming cosmic trips. Leave your comment below. Which part of the universe would you like to explore?